Welcome to our free webinar about the arc flash study cost. What should you expect the estimate to be based on your facility, the type, the size, all that wonderful stuff. We'll dive into how you can estimate what range you might be looking at there, but also considering, well, what's the return on investment? Because it could actually be a lot higher than you realize. One thing I want to point out is that all of our previous free webinars are recorded and posted on our YouTube channel. So look for Herzig Engineering, and there's a playlist called Free Electrical Safety and Lotto Trainings, the recordings from our live webinars. In today's handout, there is this slide with the link to that YouTube channel. Okay, so go find the handout tab, download the PDF for today's slides, and right there you'll be able to click on it and go straight to that playlist so that you can go watch any of the previous trainings that you might have missed out on or just want to go back and have a refresher. For today's training, we're going to overview the arc flash study process. Now, we have a whole other webinar that we've done on that arc flash study process, and I'm not going to go into a whole bunch of detail here today just because of time constraints, but if you want, it was an entire hour-long webinar over the steps taken in a study and the recommendations you can implement and things like that. So go to our YouTube channel and look up that for more information there, but we'll cover the highlights today. Then we'll dive into the meat of today's topic. What is the cost? What gives you an idea of what the estimate will be? How do you determine the amount of work that it's going to take to get an arc flash study done? And then we'll compare that cost to the cost of having an incident. And the numbers might surprise you. And then we'll just wrap up talking about how to ensure that you have a study and that it's accurate and compliant. Not all studies are created equal. And of course, if we have any time, we'll open it up for questions and discussions. There is a chat feature in GoToWebinar that you can use, or a question box. That's how you can interact with me today. So if you have any questions, comments, concerns, feedback, just pull that up, let me know, and we can address it real time. I've got it right here. I'm watching it as we go. So without further ado, let's dive in. What is an arc flash study? What is the process that you might go through to get one done? Well, the first thing we need to recognize is that, well, arc flash is a very real and prevalent hazard, especially in three-phase systems. There's a lot that can cause an arc flash. Tools being dropped in, pests, it could be damaged equipment, degrading equipment. There's all sorts of things that can cause an arc flash. And it creates blinding light and pressure and sound waves and vaporized material, molten material, shrapnel, and it all happens in a fraction of a second. So, because of this, it is vital to predict the severity of those potential arc flash incidents and protect your workers or yourself from life-changing injuries or fatalities. Okay, so how do we do that? Well, we have to do an arc flash study so that we can be prepared accordingly. What is that? Well, in the NFPA 70E, the definition is right here. It's a component of an arc flash risk assessment used to predict the incident energy of an arc flash for a specified set of conditions. In other words, an arc flash study doesn't take care of all of your risk, but it gets you leaps and bounds ahead of, well, any facility that doesn't have one. It's a component of your arc flash risk assessment to tell you how severe it might be if it were to happen based on your specific system installations. So that'll help you understand, well, what PPE needs to be worn. How far out is that hazard boundary? Most important is keeping people safe, of course, but also it's for compliance. National Electrical Code, NFPA 70E, NFPA 70B, NEDA standards, OSHA, everybody agrees that this is a hazard and you need to address it appropriately. Have a study done and know what to do to protect yourself and others. So what is that general process? Well, first up, it starts with data collection. Someone going on site and going through every little piece of information that we can find about your electrical system. The wires, the breakers, the fuses, the relays, the motors, the transformers, all of it go into that data collection process. Then we have it engineered into an arc flash study using something like Easy Power or ETAP or SKM Power Tools. We go ahead and plug it into some program so that an engineer can analyze that data and run the studies accordingly. And then we give a chance for a client or the person having that study done to review the data, make sure it makes sense. If there's any recommendations made, then sure, we can go ahead and implement those prior to printing the labels. That way you have a lower hazard level on your equipment if you actually implement the recommendations. Then we go ahead and prepare the labels, typically in office. We just go ahead and print it ourselves, higher quality control that way if our hands are on it from start to finish. And then go back out and apply those labels. This is very important. If you don't get them on the right pieces of equipment, they're kind of useless, right? So, in fact, it could be more dangerous if you don't put it on the right piece of equipment. So we like to send our guys out, again, to go and verify that the data is still correct, that there weren't any changes between data collection and label app, and that all the labels get on every single piece of equipment that they're supposed to. And then you get a finalized report. Okay, so again, just high-level overview here. During that data collection process, this is so pivotal. I've heard a few people say it at this point, and I think it's just a phenomenal phrase: bad data in, bad data out. Your Arc Flash study is only going to be as good as the data that's collected and put into that software. So if somebody misses a wire or a panel or a load that is going to have impact, or maybe they've missed an entire transformer, I've seen that in some other reports before, where, it's a totally wrong voltage even labeled. Okay, that all impacts the results of the study. The calculations are going to be drastically different if you don't collect all of this information accurate and completely. Okay, so the energy sources, the protective devices, any other elements that go into an Arc Flash analysis as outlined in IEEE 1584. Then, as part of that engineering analysis, we input that data, again, very important to have the correct stuff written down to begin with, input that data into a program and create a one-line diagram and run all the studies needed to perform that analysis. So short circuit calculation, incident energy analysis, we can do a protective device coordination study. Again, guys, I'm just hitting the highlights here because we did a whole hour webinar about this process previously. But you get that diagram, and with that, we can then use it to create the labels. The data comes off of that system analysis, the one-line diagram, the calculations are run, and then we can put the results onto these labels. This is just an example of what they might look like. It includes a lot of information, I admit, but that's where training comes in. You have to know how to use the label in order to make it worth your time and effort, right? So workers who have to access equipment need to be trained on what all these aspects mean and how they apply in your workplace. A big part of that is knowing, well, okay, with these kinds of labels, this is the type of PPE I wear, and this is how far the boundaries have to be. In other words, how far back everyone else has to stay at a minimum. So these labels are your stop point. This forces people, if they know what they're doing, to slow down and think about, I'm about to get into something that is hazardous. And if I'm not prepared, I could be exposed to life-changing or possibly life-threatening injuries. So here's the things I need to wear: X, Y, and Z. Safety glasses, hearing protection, arc-rated balaclava, and arc-rated face shield, shirt and pants worn properly, no tears, no flammable stains. I need to have my good leather work boots with both sets of gloves, the rubbers and the leather protectors. All of that goes together to keep me safe. That's what's on the labels. That's what you're trying to get out of this analysis. It's also going to show you whenever you don't have PPE to protect yourself. So you'll get danger labels. No adequate PPE for this level of hazard because you don't simply have a suit rated high enough to get into that safely. Now, it doesn't mean that you can't work on it ever, but it just means that there's going to have to be some additional steps, some additional risk controls put into place. You don't know what the results of the study are going to be until it is completed. Okay, so these labels coming from that very specific calculation done by engineering, this could be a matter of life and death, whether or not you know the results of these studies. Okay, so these labels get put on all your electrical enclosures, at least they should. So panel boards, disconnects, even control cabinets, so to speak, that have three-phase conductors in them, switchboards and switchgear, motor control centers, even overhead bus ducts. And when it all is said and done, you should have detailed reports on your Arc Flash study. Again, note all the data that was put into that calculation so that if something changes, you can mark it up and let us know, or let your provider know. All those labels, records of what they said and how that result came to be, and your one-line diagrams. Okay, again, way more detailed information in one of our previous webinars called the Arc Flash Study Process and Common Ways to Lower Arc Flash Hazard Ratings. So not only do I go into more detail about each of these steps with a coworker, but also telling you, well, how do you lower those hazards? Again, right there. Go to our YouTube channel, watch a previous video there. Okay, so what are the cost estimates that we can expect? Well, let's start with the Arc Flash study, actually getting that analysis performed. The different variables could include your type of facility, how large is it and where is it located, what is your operation, is the equipment easily accessible or not, do you have current electrical installation documentation, diagrams and markings or not. Do you have qualified personnel at the facility that could assist with the data collection process? And, well, a big factor in cost is who's doing it? Who's providing that study? Okay, so let's break this down a little bit more detailed. For the facility size and location factor, we're typically looking at the square footage. So how much of a footprint do you have for your facility? And what is the ratio? Is it all manufacturing or is it warehouse or do you have office space? That's kind of part of the operational type, but the square footage for each of those areas is looked at. It also can change depending on whether it's a single floor of equipment or if you've got multi-level buildings. Is it a single building or is it a whole campus? And let's be honest, it also depends on where physically you're located. If we're going out to a California coastline versus middle of Kansas, it's going to be a little different cost just from the travel aspect. Then we've got operational types. So again, if it's a really dense, packed facility of manufacturing or production lines, that's going to be very different than an office space with a big old warehouse attached to it, or even a hospital or some other kind of healthcare facility or retail store. So a big part of this for your operations is, well, what does that look like equipment density-wise? How much of that square footage has electrical equipment in it? The more equipment, the larger the project, the higher the cost. Makes sense. The next big factor is equipment accessibility. How easy is it for us to even access that enclosure? For example, here, the picture on the left, we walk in and think, oh, chef's kiss, this is phenomenal. The one on the right is what we usually end up getting though, right? So it's totally dependent on what your housekeeping is like, as well as, do you have any risky locations even? Is it a hazardous classified location, like, conductive dust in the air or explosive materials nearby? Are we gonna have to be up on a roof a lot because there's a lot of rooftop units or things like that? Even something like your site security, if you have to have a clearance to be able to walk around by yourself, that adds time, because we have to have an escort of some kind throughout the whole process, door access requirements and things like that. So just generally, can we even access the equipment? The easier it is, the less time it'll take, therefore lower the cost. Another big piece is that current diagram or marking availability. If you have up-to-date one-line diagrams already, that makes it so much easier for people to estimate, well, how long is it going to take to do this job? And a quick reference for checking that, yes, we did actually collect everything that we need to. If you don't have that, don't worry. Most providers are going to give you a one-line diagram as a result of part of that study. I know we sure do. And then also the equipment markings. So is everything named? If not, we're going to have to be coming up with a naming scheme while we're there, right? So gotta have those equipment names labeled. What are the upstream sources? What are they feeding to? The panel schedules, load identification tags. Even something as simple as having that nominal voltage listed on the equipment goes a long way and saves a lot of time whenever we're trying to collect that data. The other part of it is, well, does the facility itself have available personnel that can help assist? So if they're qualified and they have PPE and they can help with things like taking the covers off so that we can see what's actually installed, yeah, many hands make light work, right? So that can make it go faster and possibly reduce the cost. If someone's working by themselves, though, it can take a little bit longer. There's more steps, more precautionary, but also just physically, time-wise, it takes longer than having multiple hands on the job. The bigger piece that varies provider by provider is, well, what is that person's quality and experience of doing arc flash studies? So who's collecting the data? You might find a cheaper study, but it's general technicians that really don't have a strong electrical background, and they're hoping for the best a lot of times. Maybe this is the only electrical experience they have, is collecting data for this. I'm not saying that that can't be the case, but they might miss things that licensed electricians or qualified engineers are well familiar with. Who's doing the engineering part? Definitely there are options out there where during the site walkthrough, they're plugging and printing the labels right there, ready to go. But how do you get a PE reviewed study, and how do you have quality control and checks and balance in place there? Well, that's something to consider. And then, of course, who's applying the labels? Sometimes it's just giving a stack of labels and a set of drawings and saying, hey, whoever you want to go around and label these enclosures, go for it. But then we come out a lot of times and see they're applied on the wrong pieces of equipment, or they're not applied at all. They're still in that stack, sitting in someone's drawer. So we always go on site, unless, absolutely told we can't, and want to apply it ourselves and verify that the data is still accurate. And also, just gonna say this, if we do the study and there's a need for your own personnel to do the label application, maybe it's a cost-saving thing, fine. We'll do what's called a virtual label app. So one of our qualified personnel are still on the phone or video chatting with whoever is applying the labels at your facility to make sure it gets done properly. So even if we're not physically there, we are monitoring that process, because the last thing we want is for a label to end up on a wrong piece of equipment and someone be horribly underprotected when there's an event. Okay, so all of these factors go together to give us an idea, an estimate of what that cost might be. Now, big piece of that is your facility size. Second big piece is equipment density. What kind of equipment are you doing? What kind of process are you doing? Okay, so small facilities that have 1 to 2 small buildings, we're looking at 7,500 to 15 grand. That's quite a big range, right? Again, it all just depends on what you're doing, and those are the factors that we talked about. Medium, few more buildings or larger buildings, multi-level, we're looking, 15 to 35. Again, totally dependent on all the factors we've discussed. Some of those large complex sites that have just sprawling acreage of different facilities and operations, major massive meta centers and things like that, yeah, it's gonna be on the higher end. More equipment, more square footage, more to engineering, more to include in the engineering analysis. Okay, hopefully this isn't super big sticker shock to some people. A quality study requires some investment, but is it worth it? Is an arc flash study worth the cost? Absolutely. And I hope everyone who's sitting in this webinar today can agree, especially whenever you consider the cost of an arc flash incident. Of course, there's the potential of equipment downtime, you needing to have equipment replaced, a switchgear or panel or whatever it is that blew up needs to be replaced now. Other equipment in the area could be damaged as a result, not even just what caused the arc flash, but anything in the surrounding area, material loss, downtime. But there's also the potential for OSHA fines and lawsuits, or even injuries, worst case fatalities. Okay, so it is absolutely worth the cost. Because this is such a big people issue, I'd like to spend a few minutes of this webinar today looking at Donnie's accident. Donnie had PPE, but did he know if it was enough? Did he have his protection? Was his workplace in such a culture that they prioritize safety? Well, let's listen to his story, and I think you can answer those questions.
I got up early that morning. I was going to go to work to hook up a generator. before the Hurricane Charlie moved into Florida. When I left that morning, I just figured it was any other day. I guess you don't wake up in the morning thinking that you're gonna be in an accident.
911, what's your emergency?
We need an ambulance quickly. We just had an accident.
Sometimes when you get in that kind of situation, you kind of just have to break it down to the hour and the minute, because if you look at the whole day, it's pretty overwhelming.
What's the problem?
My coworker, he's badly burned. He just got caught in a fire.
Is he
Flash arc fire.
Is he conscious?
Yeah, he's conscious.
I haven't done this 1,000 times. I've been an electrician for 20 years. I didn't need to wear my gear that day. I guess I was too good for it.
Can you tell me how many have been injured?
He's the only one, but he's in shock. He's got severe burns.
Donnie's service call was to go out, hook up the wires from the temporary generator into the main panel, which he's done many times over.
My job for the day was to hook up a 3,000 amp generator to a 3,000 amp electrical service. After I tested the generator power, I went into the main building electrical to test it. And I opened up a small panel for their main switchgear, their main breaker panel for the entire building. I clipped A phase with one alligator clip. I clipped B phase, and as I went to clip C phase, the meter blew up and blew a puff of carbon into the electrical box. Well, this set off an electrical explosion between all three phases. We
got a phone call that there was an accident. I was told that there was a flash in the electric room, and the electrician on site was injured.
I didn't realize at that time how badly I was hurt. The one maintenance man told me later that he thought I was dead because there was no way somebody could stay alive through that explosion. Looked down at my arms and hands, and I realized I was really burned up this time.
They told me my husband was calling, but it wasn't. It was another man. And he just said, I just have to let you know your husband's been in an accident. He'll be going to Tampa General, but he is walking and talking. I just literally threw the phone, grabbed my purse, and ran. And all the way down the road to the hospital, I was wondering, who do I call? What do I do?
One of the first things I thought was, this doesn't happen to me. You know, this is something that you hear about in the safety films, or somebody's friend that had this happen to them. It doesn't really happen to me.
They didn't recognize him because he was charred black. That was hard to see. Then he started getting infections. And I remember sitting there being talked to as if he may not make it through this. His waking up was very slow. It was just opening the eyes at first and not really being able to talk. I think he, like the first day, he was asked to respond by blinking.
After that point, they tell me I was asleep for a month and a half.
Once he woke up, I felt like, okay, now we're getting better. Now it's on the way up. And I don't think that any of us realized how long the recovery would be.
One of the first memories I have is my son walking into the hospital room across the foot of the bed.
When I first talked to my dad after he woke up, I saw he was definitely still the same person, but his body was just so small and shriveled, and he'd been through surgeries at that point. Later on, the number would total to about 6 or 7, and he'd have to go through hours and hours of therapy and rehab. He had to relearn how to walk. He had to relearn how to use his arms.
You know, I told my wife once before we got married that as long as I had these, we would have money. Well, I almost didn't have these. I almost lost my life altogether because I wasn't wearing the protection.
Less than 3 minutes of putting on his safety equipment would have prevented him from being in a coma for over 30 days, as well as a year-plus recovery.
Being safe is a lot easier than putting yourself through and your friends through and your family through what my family and I and my dad had to go through. It's just easier to put on your safety equipment.
If he would have taken that 2 to 10 minutes of time to put the gear on, work a little bit slower, it really makes you think that it's okay to be a half hour late.
As fortunate and blessed as I feel today, I could have avoided all of this that I put my family through, that I put myself through, if I'd have just taken that 3 minutes to wear my PPE.
Donnie, all things considered, kind of got lucky. You know, there's a lot more detail if you go to donniesaccident.com about what happened exactly. Part of the problem is that he got complacent. He didn't think he needed PPE. But how would he have known what to wear to begin with, right? You got to have the study done to avoid people ending up looking like this. This was Donnie in the hospital after his incident and after some procedures had already come and gone. He was still in his coma at this point, I believe. So yeah, we've got direct cost issues that we need to be concerned about, such as equipment damage, having to replace or refinish or recondition that equipment. There's, of course, operational downtime, possibly even entire facility shutdowns, depending on how bad it is. That's a lot of loss of revenue. There's also workers' comp and medical and time away. You know, less about losing money for the business and more about the cost of just trying to get this person back on their feet. And then there's the kind of loss that's beyond comprehension, that nobody should have to experience because they were left unprepared or unaware of fatality. There was a quote in an EHS Daily Advisor article called "Don't Let Arc Flash Cost You" that summarizes the cost pretty well of an arc flash incident if you're caught unprepared. The average medical expense for an employee who survives an arc flash is $1.5 million. The price of litigation and settlement in arc flash cases, she found to be between $5 and $10 million whenever looking back at the cases available to review. That's absolutely incredible in the worst way, right? Think about that time spent in the hospital to rack up $1.5 million, the surgeries, the skin grafts, the therapy after. It's just life-changing, life-altering. So yeah, between direct and indirect costs, it can easily cost you upward of $5 million. Plus, there's that loss of reputation and potentially loss of employees. So arc flash, it can be fatal. That's why you gotta take steps to prevent it. You have to identify how severe it might be to help prevent them from even happening. And if it did, know that you're prepared. You know how far out it can still hurt people, and people who are in those boundaries are wearing the right gear. You have to be sure of that. So how do you make sure that your study is accurate and compliant? Well, you know, we gotta address shock as well. Don't forget about electric shock. It's a simpler hazard to address though. The severity of burn potential really comes down to completing an arc flash study. In the NFPA 70E, it talks about what needs to go on those equipment labels and all the equipment that needs to be included in that study. But those labels are only as good as they are up to date. So you have to review them every 5 years at a minimum. Again, minimum. You also should be reviewing and updating them anytime you have new installations or system modifications. And really, best practice is that you do annual data verification. It is required for generation and transmission industries though. If you have any change in utility source or change in system impedance or configuration, you know, you're refeeding equipment to different stuff, or you have larger or smaller loads attached to those distribution panels, then that all would prompt you to need to get that analysis reviewed and updated. So it's every 5 years at a minimum. So what are the key takeaways? Get an incident energy analysis performed. Get that engineering study performed. Make sure that they're applied and on the right pieces of equipment, and review and update your study every 5 years, or if something changes, because again, if the data doesn't match, that study result isn't going to help you. Now, if you do need some help, of course, we've got you covered. It's our bread and butter, has been for the last 25 years. We have Herzig Engineering studies with our arc flash labels and our equipment recommendations, mitigation and coordination, and all those things that you need to keep your system running smoothly and as low of a hazard as possible. And we include training with every study as well, because honestly, again, I argue those labels are useless unless people know how to read them. I will point out that we are licensed in all 50 states. We have engineers that are PE licensed in all 50 states. We only use licensed electricians and/or engineers, most of the time licensed master electricians, journeyman and master electricians, to collect the data. They know what to look for. They got this. Every study includes recommendations to lower that incident energy, and we have a client portal that you can access your reports and centralize your safety program. So with that, and just 1 minute after the time, I apologize for running a little bit late today. If you have any questions, please don't hesitate to use the chat feature or the question box. Otherwise, don't forget to download the handout, and you can always reach out to me later. My name is Caitlin Weininger. If you call the office, they know exactly who to send you to if you just ask for Caitlin, because I'm the only Caitlin here. Otherwise, you can email or talk to someone else. Plenty of us willing to help you. But I hope that you take this seriously and use this to help bridge the gap between budgets and safety, because in reality, the cost of a human life, invaluable. Okay, open it up for questions. Otherwise, I hope you guys go home safely.